Okay, so let's start. Good morning, good afternoon. Thank you for joining our webinar. So just remind you that the webinar will be recorded and it will be available on our YouTube channel afterwards on our geospatial webpage. If you have any questions during the webinar, please feel free to leave them in the Q&A section and we will answer them either during the webinar or after the webinar. We will get in touch with you. My name is Khrystyna. I'm the speech extraction product manager, and today I'm with our great guest speaker who most of you probably already know, Jarlath.
Hey, wonderful. Thanks, Khrystyna. It's wonderful to be with all of you. So I'm Jarlath O'Neil-Dunne. I'm the director of the Spatial Analysis Lab at the University of Vermont. And today I'm going to give you some insights into eCognition data fusion and some of my tips and tricks of having used the software for the better part of the last 2 decades. And what I hope you get from this webinar is some things that you can go out to implement that'll make your workflows better, especially when you're implementing automated feature extraction routines that have a cacophony of data, point cloud, raster, and vector. And as we get into it, I'd like to sort of set the stage on why I do what I do and how I approach things, both for myself and the team that I'm privileged to lead here. So this is a screen capture of a recent online article in which the city of Boston, which is located on the east coast of the United States, in which the mayor there announced a massive new investment in trees to help cool the city and reduce flood and just make it more livable. And this was based on the data that you see there on the right that came from our analysis, the foundation of which was done in eCognition. And so people like the city of Boston and other communities who we work with our US Forest Service partners, come to us with questions. They want to know how much tree canopy they have, how it's changed over time. And then related to this, they ask us for other geospatial analyses, such as who owns the tree canopy and what's the relationship between, say, tree canopy and the urban heat island, so that they can address longstanding issues of environmental justice. And the mapping components that you see above in orange, those are foundational things for which we use eCognition for, and it really excels. So these projects, I would characterize them as funding poor. There is not a lot of money in them. However, they're incredibly data rich. By funding poor, I mean we are not going out and flying new imagery and LiDAR for the vast majority of these. We're relying on what's out there already, and we're very fortunate that here in the United States, we have at least a decent track record of open data and access. That includes high resolution imagery, LiDAR, and then a whole host of associated vector data sets. And so when people want us to do the type of underlying mapping, both the land cover and the change detection, they really expect 2 things. They expect it to be very, very, very accurate. So if you were going to say that tree canopy is changing 2%, your accuracy better exceed 99%. The other thing they expect is that it's going to be consistent, particularly when we're doing change detection. So let's take a look at some of our workflow examples from recent projects to give you an idea of the data input. So we often have imagery from 2 time periods, and if I flip back and forth between these 2 decades, you can see there's a lot of challenges. The shadows are in different directions, the imagery is slightly different resolution, right? And there's also the associated parallax with it. We've just got buildings and trees leaning in different directions. We've also got LiDAR. The LiDAR don't align perfectly. They were required under leaf-off conditions, done using different sensors for each of the 2 years, different specifications processed by different vendors. And on top of that, we've got a whole host of vector data sets. And so from this, we produce both high resolution land cover, and then also very, very detailed tree canopy change. You can see these overlaid on the 2 different time periods of LiDAR. These are very, very high-end products. We're extremely proud. We routinely hit over 99% accuracy for the tree canopy mapping when it's independently assessed. Okay, so we also derive other products using eCognition, such as our tree centroids and our tree crowns. So it's nice for us to be able to give people a complete accounting of their tree canopy. It's also nice to tell them how many trees they have and what the size is. Okay, so now, Khrystyna, it's time for a poll. We'd love to hear a little bit from all of you on your eCognition and data fusion needs. So Khrystyna, I'll turn it over to you for the poll.
Okay, I launched the poll. I hope you see the questions. I see in the Q&A that some of you do not hear Jarlath very well. Please, if it is the case for others, let us know.
And I've turned off my video, Khrystyna, in case that helps.
Okay, almost 50% answered. Let's give it another 30 seconds or so.
Sounds great.
Okay, I think we can close it now and share the results. Can you see the results?
Yeah, great. Thanks, Khrystyna. This is really, really helpful. Looks like we've got about half of the people out here who use eCognition. In terms of data sources that people use for feature extraction, most are using imagery, but not too far after that is LiDAR. Interesting that not a lot of people are incorporating, so only 40% are incorporating vector data into their automated feature extraction workflows, and much less are even working with thematic raster data. So for those of you not using vector data in your automated feature extraction workflows, I hope to change your mind today. And on the data, a mix of internal sources and external sources seems to be most prevalent. And then I think we've probably got, we can look through some of the answers on the biggest challenge to help guide some of the questions at the end. So thanks everyone for participating. So got about 15 tips and tricks for you today that I hope will give you these insights into how you can best utilize the unique capabilities of eCognition. One is just leverage everything that's out there. No data set is perfect. Data sets are never going to align perfectly, either temporally or spatially. However, with eCognition, you can still make use of them. And the biggest mistake that I see people make is not leveraging vector data out there. There's just so many different sources of data, from road center lines to building footprints, maybe building centroids, sometimes even property parcel data, existing land cover that has been mapped. Even if it's at a moderate resolution, this can be incredibly valuable. So I'd encourage you, in addition to making use of the imagery and LiDAR data out there, to make use of the vector data as well. One of the wonderful things about eCognition is we can bring in LiDAR point cloud data, LiDAR rasters, imagery, thematic rasters, and vector points, lines, and polygons all into a single integrated feature extraction workflow. And you can see just a screen capture here from one of our projects, an example of the type of data that we have. We've got leaf-on imagery. It's not loaded in at this time, but also leaf-off imagery. We've got LiDAR surface models. We've got a LiDAR point cloud, and then we've got various vector layers. And all of these different data sets have their strengths and weaknesses. None of them are perfect, but we can derive value from all of them thanks to eCognition's workflows. Second thing is, when you're working with large projects, really think about your tiling structure. So eCognition gives you the capability if you have an eCognition server license to do what I call internal tiling, which means you tell eCognition to tile up your data and then you can distribute it to multiple processing cores. However, if your data come tiled already, make use of that tiling structure. And so in this particular example from a recent project, each one of these yellow squares that you see here, that represents a LiDAR point cloud tile. It's in LAZ format, so the compressed format of LAS, the ASPRS standard. And so each one of these represents an individual point cloud. So what we did is we made use of tip number 3, which is eCognition's robust customized import routines to automatically scrape the directory that contains all of those point clouds and load them into our workspace where they each become a single project. Okay, so this is what that looks like within eCognition. So this is the workspace, and each one of those file names that you see there on the left, that is an individual LiDAR point cloud. And you can imagine it's not feasible, right, to stitch all these point clouds together into a single LAS file or LAZ file, even with the LAZ compressed format. That would probably be hundreds of gigabytes to potentially terabytes, far too large to effectively work with. And also, when we leverage tiles, we can distribute during the processing phase each one of these to an eCognition server license for batch processing and more efficiency. The customized import routines within eCognition are robust and powerful. And so in this particular case where we were scraping a directory of LiDAR point clouds, I'd like to just walk you through the steps. There's a wonderful video on the eCognition TV channel that shows you how to do this. So step 1 is selecting the root folder that contains that entire collection of the LiDAR point clouds. 2 is the master file. This is a representative file of the data set that I'm working with. So in this case, it's a LiDAR point cloud. Step 4 there is specifying the search string. So I've added some additional information in here, and this is really wonderful. So I specify that the units are in the US survey feed, something that we're finally getting rid of here in the United States. Will be on international feed like the rest of you, and maybe in 20 or 30 years, we'll finally be on the metric system. And I'm also with the @res there, setting the cell size or the resolution to 1. And when I press the test button number 5 there, you can see that it shows me what my search is doing. So this is a simple way, without having to know any scripting language, where you can scrape a directory containing all of that data. And if you have data in stacks, if your data are tiled, your imagery and your LiDAR tiled the same way, you can use that as well. And I always encourage you to make sure that you go over to the image layers tab there and specify the alias so it's something meaningful. Aliases are great. Not only do they make your life easier when you've got multiple layers and data sets loaded into eCognition, but they also increase the ability of you to transfer your rule sets to other projects. All right, and this is what the project looks like once I've brought in everything with that customized import routine. Each one of those LiDAR tiles represents an individual project. And then I use that project as the foundation for bringing in my other data. So quite often in our workflows, we're working with tiled LiDAR point clouds, and then we also have raster mosaics. And one of the things that I love about eCognition is I don't have to have everything assembled and structured the same way. So let's go back to the example here. You can see this area, that grid there, that's the structure of the LiDAR point cloud. The imagery that you see there, not only does it cover a larger area, but that is a single file. It's a single image mosaic. And I don't need to load that in during the customized import routine. I can actually load that image data set in my rule set using the create modify project algorithm. And the little tip around this is that when you load data in, especially if it's multi-band imagery, make sure you use the create modify project for each and every band in your image data set. In this case, it's aerial imagery, and it has 4 bands associated with it. I use a variable up front to specify the path to that particular raster data set, which is a geotiff. And then I bring that variable in when here's me setting up the variable, which is the path to that particular raster data set. And then I use that variable called leaf on scene path when I use the create modify project algorithm. And the beauty of the create modify project algorithm is that when I have an individual LiDAR tile, such as what you see here, when eCognition loads in that giant raster mosaic, which covers a much larger area, it virtually clips it down to the extent of that LiDAR tile. And this is just brilliant. It's such a time saver when we have all these raster mosaics out there and these LiDAR point clouds. We don't spend time retiling our imagery to match our LiDAR data. We just create a workspace using our LiDAR point clouds with the routine that you see here. And then as part of the rule set, so you can see that over on the right on the rule set, we load the data in during rule set execution. Really makes the process seamless, and we don't have to do, I think, sort of some of these overcomplicated customized imports where you've got to make sure that you grab all your data at once. It makes recreating the workspace easy. It makes reverting the workspace back to its original state easy, and makes the rule sets very flexible and transferable if we need to swap out data along the way. Really great functionality there. So tip number 5, we saw from the poll that a lot of you are not making use of vector data in your feature extraction workflows. And this really surprises me because I have a tough time thinking of anywhere in the world where there's probably not some sort of vector data or maybe raster thematic data that already maps features of interest, or at least can inform mapping. That may be a coarser resolution land cover data set. It could be building footprints that perhaps are just a couple years outdated. It could be road center lines, or it could even be things that help to inform the feature extraction process, like property parcel boundaries. I'm always shocked when I see people developing road polygon extraction algorithms for areas where there's already road center lines and they're not leveraging them. So make use of the wonderful data sets you have out there. And what's great, once again, is that eCognition allows you to work with vector point lines and polygons. So in this particular case, I'll just show you how we leveraged existing water data for this project. So these are water polygons. I will say that they were not perfect. Okay, their delineation of the water features was neither comprehensive or accurate. However, they reduced our mapping workload, I'd say around 80%. And so that was quite valuable. So much like when we're working with raster data sets, we don't load these in during the customized import routine. We load them in during rule set execution. And that's this algorithm, same one that we use for the imagery, called create modify project. So with create modify project, what I can do is I can specify the path to, in this case, this shape file representing water polygons, and then I can give it an alias, which I've called it hydropolys in this case. So what that does is that loads in that very large vector data set, and much like we saw when we loaded in the imagery, it will automatically clip the vector data set down to the project that I'm working with, which is that individual LiDAR point cloud. Over on the left there, you'll notice that I now have a vector layer in my project called hydropolys, and I can set the symbology both for the outline and the fill. And Khrystyna, I just wanted to pause at this point in time, see if there's any questions that are related to what I've covered so far. I think I see something in here around segmentation. We'll certainly get to that. But are there other ones you think it'd be worth me covering at this time?
Yeah, there are a few questions. One from Camille. Would it work to take advantage of tiling the other way around, to use the tiled imagery as the basis versus slider point cloud?
Yes, you could certainly make use of tiled imagery. Customized import works well with multi-band rasters as opposed to sort of single layer point clouds or single band or single layer raster files. And if you have your imagery and LiDAR data tiled the same way, you can batch in everything. So you can use a customized import. So let's say my imagery and LiDAR point clouds and LiDAR surface models all use the same tiling structure. I could run a customized import routine that would scrape those respective directories and stack them all into a given project. It's really quite powerful. Are there any other questions, Khrystyna, right now?
Yeah. Is it possible to create data processing templates and run them on the cloud, processing data and creating results from into cloud storage buckets?
I think I'll need to think about that and get some clarification. Khrystyna, you might be able to weigh in on that, but perhaps we could save that one for the end, if that's okay.
Yeah, that's fine.
Right. Yeah, sorry, we'll come back to that. So tip number 6 is to automate data display. This is one of the most overlooked features within eCognition. So I love visual analysis of data, right? It's it's the foundation of how I approach feature extraction, right? I really need to see what I'm looking at. And one of the reasons why I love eCognition is you're not just sort of writing code behind the scenes. And so many of the problems I see with machine learning and artificial intelligence nowadays is that people are developing code and they're running things and they're looking at all these statistics and output, and they're not actually looking at the data. And if you spend time looking at the data, you can really develop an understanding of its strengths and weaknesses and how you can leverage those respective data sets. And eCognition makes that easy to do. You're able to set up layouts such as what we see here, where I've got imagery in one panel, I've got LiDAR intensity and some vector data in another panel, and I've got some different LiDAR surface models displayed in the other panels. I can sync these panels so that when I zoom in and zoom out and pan around, they're all aligned with one another. And this is really a great functionality with eCognition. And one of the things where I see people spending a lot of time is maybe as they're working through hundreds of LiDAR tiles and testing their rule sets on different projects, is they're resetting the views every single time. Well, eCognition has some wonderful algorithms to assist you with this. These are in the rule set. So when you run your rule set, you can execute these processes and it will say define your view layout. So here I can say split my view into 4 panes, set them side by side, and synchronize them. Okay, so we can see that the algorithm defined view layout there and the algorithm parameters, that sets up the view layout. And then I can use a different algorithm, set custom view, and this will set the view on each one of those panes. So for example, here I'm saying on the first pane, I want you to display these 3 bands of imagery that you see down at the bottom there. I can even set my image layer mixing. And here we can see on the second one, I'm going to display a LiDAR surface model. And you can see that my display settings there are a little bit different than what I'm using for the imagery. And this gives me a consistent and automated approach to displaying my data for each and every one of my projects, whether I'm working on it or one of my colleagues. It really, really streamlines things. It's wonderful. Tip number 7. You can create new raster data sets within eCognition. When we're working with our LiDAR surface models, and quite often these come to us as part of the LiDAR collect, so they're generated outside of eCognition, and they come in addition with the point cloud. However, we would like to generate additional LiDAR layers that either help us with the visual interpretation or the automated feature extraction. An example is slope. And if I wanted to create a brand new slope layer from a LiDAR data set, especially a mosaic raster that is perhaps hundreds of gigabytes, that could take hours or even days. And what I love about eCognition is it has specific algorithms that allow me to do things like surface calculations or image or raster layer subtraction, or even generate vegetation indices like NDVI. These all can be done in eCognition, and it's so time-saving if you're working with very large data sets to make use of these different image layer algorithms like surface calculation to generate your data within eCognition. eCognition will produce those layers, and when you've finished running, you can choose to export them, or they'll just go away. So in this case, you can see I'm running a slope on my LiDAR normalized digital surface model. So this is the height above ground, sometimes called a canopy height model here. And so I'm running that surface calculation. I'm producing a slope layer. I only have a desire to use that within eCognition. I'm not going to save this when I'm done. It's just part of my rule set for both feature extraction and visual interpretation. And then when my rule set is executed, that layer will go away. Really, really handy. And quite often we are generating several to sometimes over a dozen raster layers. Sometimes it's subtracting raster layers. Sometimes it's deriving new ones using things like surface calculation or NDVI. Perhaps you want to use NDVI for segmentation. You can generate that within eCognition, use it in segmentation, and then when your rule set's done, that layer will go away. Really, really nice. So tip number 8 here. Don't worry about, maybe I should say, don't overly stress about the alignment between your data sets, right? And this is where I also see people spending a lot of time trying to get, say, their imagery and LiDAR and vector data sets to align perfectly outside of eCognition. It's really a waste of time because you're just never going to get there. Imagery, quite often, just the nature of it, you're going to have lean with the buildings and trees. The vector data may have been created from other sources. It could be outdated. It's just not going to align perfectly. With eCognition, you can apply some intelligent logic. You don't have to use fancy artificial intelligence and machine learning. You can apply some intelligent logic to deal with these issues. And so in this particular instance, you can see image objects I've generated through the use of a multi-resolution segmentation algorithm. And like me, you've probably seen all of these papers that talk in depth about how they set segmentation parameters. I don't put a lot of stock in those. I think it's a lot of wasted time. My approach is to say, hey, what layer is the most spatially accurate? In this case, it's my LiDAR data set. And what's nice about this is that by applying the segmentation to my LiDAR data set, I've got the best representation, in this case, of above ground features, my trees and buildings. And now, even though my imagery and my LiDAR don't align perfectly, because you can see this object highlighted in red, you can see that that object is part of the tree canopy in the LiDAR. And then in the imagery, it's a mixture of trees and LiDAR due to the lean and the less spatially accurate characteristics of the imagery. I can still work with that just fine, because what I can do is I can build then automated routines with an eCognition that say, if these objects have characteristics of trees in the LiDAR data, and then they have at least some pixels with high NDVI in the imagery, then call them tree canopy. And so we've got a lot of ways which we can work on this, and we can make use of the best possible layer for our segmentation, such as the LiDAR in this case, and then leverage the imagery in other instances, right? And perhaps this works really well for trees. If we're going after impervious surfaces, the LiDAR surface model is not the thing we want to segment on. Probably want to segment on the imagery. And so we can segment multiple times. And typically when either I'm developing rule sets or members of my team are, we'll segment the data maybe a dozen, 20, 25 times, different segmentation approaches for different features. Okay, so this gets into tip number 9, which is chaining segmentation algorithms together, right? And this helps to move you away from the perfect segmentation. You're never going to find the perfect segmentation in general. You're certainly not going to find a single segmentation algorithm and single segmentation algorithm parameter settings that work for all of your features of interest. If you're mapping both individual trees from LiDAR and imagery and water bodies as part of a land cover mapping project, those features have very, very different characteristics, both in terms of their size, their spectral characteristics, and their height characteristics from the LiDAR data. A single segmentation algorithm is not going to work well. So quite often what I'll do is I'll say, apply a multi-resolution segmentation algorithm. In this case, it's applied to various LiDAR layers. And then maybe I'll use a different segmentation approach, like multi-threshold segmentation, to then refine that. So you're not stuck using a single segmentation. I think that's one of the real drawbacks of most of the stuff that I see in the peer-reviewed literature, is people are really bent on finding these optimal segmentation parameters when you don't have to be constrained like that at all. Find the segmentation parameters that work well for perhaps delineating trees from LiDAR, and then when you move to those water features, feel free to use an entirely different set of segmentation parameters. And thanks to the fact that you can control what classes you apply the segmentation to using the image object domain, with an eCognition, you've got tremendous power, right? So in this case, I'm controlling this particular segmentation algorithm to those features that are unclassified. Okay, tip number 10, really leverage point cloud classes. So eCognition has a very nice point cloud classification algorithm. Increasingly, we find that LiDAR comes to us and that the point cloud classes are pretty decent. Once again, not perfect, but they tend to be perhaps 80 or 90% accurate in a lot of cases. So this is the example here of a LiDAR point cloud that came to us. The orange classes there are the ground. The gray is unclassified, the red are the buildings, and then the green is tree canopy. So overall, this looks pretty good. Where you see that blue arrow pointed to is a building that's classified as tree canopy. All right, and I could spend a lot of time trying to rerun a new point cloud classifier, and maybe it would get this building, but then it would create issues in other cases. However, in eCognition, I'm not constrained to just working with the point cloud. That's the real limitation around point cloud classifiers, that all the information they have is a point cloud. With eCognition, I can bring in imagery, which is very, very useful for this. And then I can also bring in perhaps existing vector data. It could be if there's any building footprints out there, polygons, or even address points that I can leverage to fix these. So we're able to quite often do far superior feature extraction than you can ever get with a point cloud classifier, either leveraging eCognition's point cloud classification algorithms, but particularly through data fusion. So let's take a look at an example here. So in this particular case, I've already segmented my data into a category called tall. So that's everything that met a certain height threshold. And here I've created a condition that just says, if the percent of building points in the point cloud that are above ground, I want to assign these to a class called building candidates 1. Okay, so very, very simple logic here. I've just done a segmentation and then a classification, and this is going to get me a lot of the way there. And so with eCognition, you can create customized features. If you've never used customized features, it's one of the more powerful capabilities. You could, for example, generate NDVI. In this case, I've just done some simple math here, and I've said, use the number of points on the LiDAR point cloud that are fall into class 6 on the left here for building, and then divide that by the number of points in the other class, and then multiply that 100. So this just gives me a percentage of building points. Over on the right there, I can see I've got a percentage of tree points. And this is particularly useful. I love the percentage one because my objects are often represent features better than the point cloud classifiers can. And particularly with some buildings, sometimes we'll see tiny little trees, say, show up where chimneys are or complex roof structures. By using object-based approaches to evaluate those points, I can improve the point cloud classification and improve the the resulting land cover classification. Okay, Khrystyna, I just wanted to pause there, see if there's any questions relevant to the topics I covered.
Do you mind answering the questions after the webinar, so we can just go?
Sure, yeah, absolutely, no problem.
Perfect.
We'll keep the momentum going, and I think we'll have actually plenty of time for questions. Tip number 11 here. We've got 15 tips, so I think we'll probably wrap up in the next 5 or 10 minutes or so to make sure we can get to those questions. So tip number 11, make use of sub-objects here. And sub-objects or image object level hierarchies are very valuable, particularly when we're doing data fusion type things. And so let's come back to that building here that was classified as tree canopy. What I've got overlaid here is in red are the building footprints. So these are existing vector data. Now you can see that they were derived from a data set that's not as spatially accurate as the LiDAR data. And so there's some offset there. However, the nice thing is here, and why you see that area highlighted in that pink or that magenta color, is I can run routines that say, hey, bring in the vector objects on a super level, create objects of them, and look beneath them and say, hey, if I've got things that look sort of like buildings, even if they're not classified correctly in the point cloud, if they show up in the thematic vector layer, put them into this magenta category because I want to reevaluate them. So sometimes that's portions of buildings that you see there. If you look at that larger building to the right of the arrow, you can see portions of the roof there. Those were actually things that were classified as trees originally, and I've identified those as problematic because they're within an existing building footprint. So here, these building footprints are not of high quality. I'm not actually using them as the final product, but I'm certainly leveraging them to find areas where my point cloud classification might be problematic, right? I could do building extraction without them, but this is just helping me save time, right? Someone's invested money in this. I'm going to make use of it. And in some cases, if we have a partner who says, hey, I really want you to stick with those building outlines, don't shift them, we can make use of that as well in eCognition. So tip number 12, and I've gotten into this a little bit already. This is what I call targeted resegmentation, right? So this gets into this philosophy that you shouldn't expect and you shouldn't hope to have just a single segmentation routine that's going to be perfect for all the features that you want to extract. Okay, so let's take a look at a little workflow here. So I've got 3 panels here. So Over on the left here, that's my initial segmentation and classification. So I did a multi-resolution segmentation, and I'm trying to separate out the buildings and the trees initially. So I'm focused first on the above ground features. I'm not using a single segmentation to try get buildings and trees and water and driveways and roads all at once. I'm really focused very, very heavily initially on the above ground features. And I'm using the LiDAR data because it's the most accurate data set to do with that. In the middle there, I've identified some objects of interest. So these are areas around building edges that, due to the properties of the LiDAR, resemble tree canopy. They've got high numbers of returns. They show up as tree canopy in the point cloud classifier. So on an individual point or on a small collection of point level, they look like trees. However, to a human, we clearly see that those are not trees, that those should be part of the building. So I've run a simple routine that says, hey, if you have things that are have these properties, right? So they've got a high number of returns, but they're close to buildings. Let's focus on them. However, I noticed those objects were a little bit too big for me to do subsequent refinement steps. So what I've done over on the far right there in green is I resegmented those into smaller objects so that I can apply additional refinement classification algorithms. And this is using the image object domain, which works very, very similar to, say, if you're an ArcGIS user on a selection, right? If you select a number of your polygons and then you do a calculation, it only runs on the selected features. The same is true using the image object domain. So in this case, I constrained that additional segmentation run to only focus on those magenta features of interest, which are at the interface of building edges and sometimes adjacent to trees. And now I can reevaluate those because some are actual trees. And I'm going to do that using my relative border to tree canopy, and others, which are long and thin and share a high relative border to buildings. Those ones are definitely part of the building, and I don't want to classify them as trees. So I've opened up a lot of options here for refinement to make my resulting land cover data set extraordinarily accurate, thanks to eCognition's capabilities and some simple logic here. Okay, tip number 13 here, reuse routines. We covered variables a little bit when I was discussing how to load data in, how I could have just a simple string variable that I could use to specify the path to my image data set and then use that over and over again. And I was loading all 4 bands. Can also use it for segmentation routines. So oftentimes I want to resegment things, and I'll have a little resegment routine that I use over and over again. And so here you can see my multi-resolution segmentation region grow algorithm here. And over on the left there, it specifies active level and active class. And then over on the right, it specifies target class. All 3 of these are variables, okay? Active level is a level variable, and active class and target class are class variables. So eCognition allows us to have string variables, numerical variables, level variables that reflect our image object levels, and it also allows us to have class variables. And by leveraging these variables, I'm able to create some very simple reusable routines. So they have an algorithm called update variable. You select the variable type. In this case, I'm assigning a class variable. I'm assigning the class _tall down at the bottom there to the active class variable. And so this way, when I run that routine, if we go back up, active class there is the tall class. I can also do that for image object levels. So here I'm assigning things on level 2 to the level variable active level. And so this way, if I have a collection of routines, maybe they resegment things and then they classify things, I don't have to go in and change all of my domain and parameter settings. I can simply update the variables ahead of time, and it gives me a lot more flexibility there in terms of reusing these, both within my own rule set and if I want to share that with colleagues. Okay, tip number 14, make use of maps. These are not like the maps you have in ArcGIS, or there are some analogies here. So what a map is I like to think of it as almost like an alternate reality, in that you can create an entirely separate world in which you do segmentation and classification that's not connected to your original map. And you can have multiple maps within a project, okay? And you use this algorithm copy map, and then you can run all of your subsequent algorithms on that map. Where this is very useful for us is when we have to do a mixture of top-down and bottom-up mapping. Okay, so top-down mapping, in this case, I'm mapping things from a bird's eye view, right? So if tree canopy is over buildings, I want to capture the trees. With bottom-up mapping, I'm actually not interested in the tree canopy. I'm primarily interested in these impervious surface features. And so in this case, I accomplished both of these tasks using maps. On one map, I did my top-down mapping, and in another map, I used my bottom-up mapping. And what's really great is with an eCognition, you can have entirely separate workflows. However, you can also synchronize the maps. So when we did the bottom-up building mapping, I then used that and incorporated it into the top-down land cover mapping there on the left. So we can integrate these maps to work around restrictions of having a sort of single project with segmentation parameters, and also to do things like look at different approaches to feature extraction. So really nice. Tip number 15, questions. People always get lots of questions. I often get a lot of emails. I wish I could respond to all of them. Really encourage you to make use of the eCognition community. It's a wonderful resource where you can post questions. And what I really appreciate is the eCognition team, people like Khrystyna and Christian and their colleagues have a wonderful collection of rule sets up there. And there is nothing more useful than downloading a sample rule set, working with the project data, and stepping through that. I recommend that people do that rather than read through the documentation. And they've got rule sets that show you everything from how to do building orthogonalization, to working with sublevels, to creating NDVI, to deep learning, to point cloud classification. Just a wonderful collection of materials out there that I think will really enhance and expand your knowledge of what can be done with eCognition. All right, so Khrystyna, that wraps up my formal part of my presentation, and I'll turn my video back on and ask you to assist in guiding me through what questions, and I'm sure there's some that are sort of really into the weeds on eCognition that you may answer, and perhaps some other ones that I can give assistance of as well.
Yeah, thank you, Jarlath. That was a really great webinar. So the questions, we have one question from Adam. Do you prefer last or derived surfaces solely due to the clip to last LUTs?
So do you prefer LAS LAZ over derived surfaces solely due to the clip? I would, and if I understand your question, your question, Adam, it's like, do I prefer using like the LAS LAZ point clouds over the derived surfaces? I would say I don't prefer either one. I want all of them in there. Quite often I find the surface models derived from the point clouds to be very valuable for segmentation. However, then I'll find the information in the point cloud itself, maybe it's the classification, maybe the number of returns, all that rich information to be extraordinarily valuable when I run various classification routines. And that's what I really love about eCognition, right? Is I can have a point cloud in there and I can leverage all the information on that point cloud, the classification number returns, and then I can have different surface models in there. Sometimes they're directly derived from the point cloud, and sometimes they're created through differencing those surface models. So hopefully that got at your question, but if not, please let me know and ask it again. What would you like me to answer? Oh, sorry, go ahead, Khrystyna.
Yeah, or I think you also did the questions, right? The last two from Stratis. Is it actually was this how do you differentiate roads from parking lots in tip number 14? Yeah, roads from parking lots. Great question there, and I appreciate you answering that or asking that question, and hopefully I can answer it. We actually did that using property parcel data. So both roads and parking lots are large impervious surfaces. However, we had property boundary data, property parcel data, and that coded the area that roads are in as the right-of-way. And then we were able to feed that into the eCognition algorithm. So we said roads can only exist within the right-of-way. And then we were able to separate out parking lots based on their spatial arrangement, these large impervious surfaces
from some of the other paved things like driveways based on their size. So really, really great example of where we could leverage thematic data that wasn't necessarily purely the roads or parking lot data. We also did have road center lines, which are quite useful as well, although they were not perfect. And I'm happy to take some of these other ones, Khrystyna, down the bottom here.
Sure.
Can too many data sets cause confusion? Is there an optimal number? I'm never a fan of saying that things are optimal or not. I think if it adds value to you as the human looking at it, I would say yes, absolutely, make use of it. If you think that data set's not valuable or you find it's causing you confusion, then don't use it. And I think this is one of the sad things of sort of the peer-reviewed literature, right? Everything has to be optimized and analyzed and quantified. That's not how image analysis has ever worked. It was always based on tradecraft, always based on experience and skill developed over time. And so what we try to do is we try to leverage to the fullest extent the existing data out there. If some data sets are so bad, so let's say our road center lines, most of the time they don't even fall within the road due to some issues, then we will skip using those because they can do more harm than good. Some other things here. You mentioned not worrying too much about alignment. Yeah, perhaps I should have said, don't overly stress about alignment. What are your tips for effectively estimating heights and extents of trees given multi-temporal, multi-sensor LiDAR point clouds? Yeah, that's a real challenge there because you can have LiDAR data acquired at different times of year with different point densities, with different sensors, where you get very, very different results on tree height. And so you can do some nice things within eCognition, like let's say you've segmented canopies and you use, say, perhaps the best available LiDAR data. Then you can say, well, find the maximum height from time period 1 point cloud and time period 2 point cloud within this object. And that can help to, I think, minimize some of the issues associated with direct pixel comparisons, because objects can often be more meaningful. How to geocoordinates calibration of LiDAR point cloud and eCognition. Based on my knowledge of eCognition, I don't think that's the software package you would use for geocoordinate calibration. Trimble has some excellent other solutions along those lines, but I think you'd really want a LiDAR pre-processing software for that. Khrystyna, correct me if I'm wrong on that front.
Yeah, you're totally right.
Yeah, thanks. From an accuracy assessment standpoint, specifically a qualitative approach, are there any general qualitative considerations one should use from extraction project to extraction project, something that's not specific? Yeah, it's a really good question, and I'm a huge fan of qualitative analysis. If you look at your data and it looks like it's going well, that's really, really meaningful. Russ Congleton, who wrote the peer-reviewed journal article on accuracy assessment, is both a former professor of mine and a friend. I love his work. However, he's quite good in being adamant that shouldn't be the only level of judgment you should use. And I think logical consistency, right? For example, if you think you did a great job because your quantitative accuracy assessment says you identified buildings with 97%, but if all of them have a little halo of trees around them because it's got a higher number of returns, that's highly problematic, right? And eCognition gives us tools where we can look at the relationship between objects and we can resegment those objects and then we can reclassify them to handle issues like that. Another good question, when making a resegmentation, should you make it in a different level or on the same level? Isabel, in that case, most often I'm resegmenting on the same level. Image object levels in a hierarchy where you've got super objects and sub objects can be really handy in some situations. In other situations, it can overly complicate things. If I do use sublevels, typically it's only for a brief period of time. So one of the examples I showed you early on was when I had an object, right, and it's got a certain amount of vegetation in there. Sometimes I'll classify vegetation on the sublevel and I'll say if it's got a certain amount of this, then put it into this category, and then I'll get rid of that sublevel. So I will use them, but I try to use them sparingly because it can be complicated just from a human cognition standpoint. Is it actually 2.5D and not a 3D model? Yeah, in the examples I showed, we do have 3D data. However, we are doing 2D mapping, and For a while, I thought, like, why aren't we doing true 3D mapping? And then I realized that actually people just, at least the folks we want with, really want things quantified at that level. However, when we do certain things like tree extraction, we will extract those trees and kick them out as 3D shape files, for example, with height information associated with them, and then we'll put them into web apps where we can do full 3D visualization and things like that. Let's see. How does eCognition classify the point clouds in detail? I think there's documentation on that. However, I think documentation always has its limits, and I encourage you to play around with those settings. And once again, don't get wrapped up in having the perfect point cloud classification, particularly if you're able to leverage things like imagery, because you can really fix up a lot of limitations with a point cloud classifier where you've done it either externally or internally to eCognition by leveraging segmentation and classification algorithms that make use of imagery. Khrystyna, that was me sort of going through everything. Questions that you think I missed that we could help address? I'm so grateful that we've got all these people who are engaged with us.
Yeah, thank you. If your question wasn't answered, don't worry, we will come back to you. We have your names and I think your emails. So yeah, we'll contact you then afterwards. Thank you, Jarlath. It was really great.
Yeah, well, I appreciate you having me on, Khrystyna. Thanks to you and the eCognition team. I'm eternally grateful for the hard work that goes on behind the scenes to make this a wonderful software package that allows us to do great things, and appreciate all of you who have joined from various corners of the world. We've got a snowy day here in the northeastern United States, where I live in Vermont near the Canadian border, and so hope to get out some skiing this afternoon, and hope all the rest of you have a wonderful day. Thank you very much.